Hi guys, my name is Rishabh Goel and today I'm doing this demo video as part of the homework assignment for cloud computing project. The objective of this assignment is to create a map reduce jobs for the randomly generated log files. As part of this project, we have four main tasks. The first task is to determine the count of different type of log message types over a predefined time interval and which contain the injected instances of the designated regex pattern. The second task is to sort the uh, counts in descending order for type error and display the intervals. The third task is to calculate the distribution of all the log types across the entire file. And the fourth task is to calculate the maximum length of each log message type. So to start the environment, so to start with the project, first we have to start the Hadoop services. So for that, we go to the location where you have installed the Hadoop. Then to start the services, we write the command dot slash startall dot sh. Once all the services have started, we can write a command jps to see that all the secondary, the resource manager, node manager, and everything have been created. So once this is created, we go to our project location. This is my project location, the root folder, and first we will run the integration test. The command for that is sbt clean compile test. So the purpose of this command is to test the integration test that we have written as part of our application. So this is the file name mrtest, and inside that I have 5 test cases, which we can see that all of them have succeeded. So once all of them are succeeded, we are good to create our jar files. To create the jar file, the command is svt clean compile assembly. This command will basically it will create a jar file that will contain all your application dependencies as well as the file. So this command will take around a minute to complete. So meanwhile, I will explain the code. So for this, I will take this mapper and its reducer. So in this mapper, what we are first doing is we are initializing the fetching the value of the pattern, and inside the map function, the value contains the entire log file, which we are splitting as list and iterating over each and every line. If we see that a line contains the regex pattern, we will split the regex pattern based on dash, and then we will pass. So let me show you a sample input. So if we see that, if you can see, uh, the first is log entry line dot split. So line is basically this log file entry, and we are splitting on the basis of this dash. So once we have split, it will create one the line log entry dot zero would be this entire thing from till parameters dollar, and the second part would be the actual log message. So once we have got the this part, now we are splitting on the basis of the spaces that we have. From this part, we will get the log message type, which is a log parser of two, one, two, sorry, 0, 1, and 2. So that we have done here. Once we have got the log message type, we are writing it to the output of the mapper, which will look something like this. Debug, and it will create a list of all the ones, error with ones, info, and one. So now the job of the so this will be our input to the reducer. So if we see like it will take a key and as well as an iterable of values in the so we have to calculate the all the values. So for that we are using the fold left operation where we have initialized our value as 0 and we are calculating the sum and writing it. So once it's done, we will get an output stored in the output directory. This file run job is where we are initializing our setting up the mappers, the combiner class, reducer, the output format, as well as the input and output location. So let's go back to the terminal. So as part of the assembly step also, it executes the test. So once this is done, we can now go to our AWS. So I've already created a bucket here for this project. Let me delete this thing. So as far we have created one input folder, and inside the input folder we have uploaded our log, and we also have created one. We have also uploaded our jar file to this location. So now once we have created our input folder as well as our jar file, we can now go to the EMR and this is the EMR dashboard. So here we have to create a cluster. So go to the advanced options and select EMR. So I am using Hadoop 3.3.1 in my local machine. So that's why I have changed the release to EMR 6.3.1 as this is the closest version of Hadoop that I get. Let me uncheck all these things as they are not needed. The cluster should auto terminate after it has completed. Now here we will upload our custom jar file. The arguments will contain the steps that basically we have to write to run our job file. So in if we were running it on our local system, the step would have been something like this, where we give Hadoop jar, the jar name. Since I have two main classes in my application, one for creating the log file and second for running the map reduce jobs. So that's why we have to specify which job we have to run, the input location and the output location. The important step is that we should not have the output folder already created as it will create an error. So this is the this is the command that we can use to delete it from our Hadoop system. So once this is done, let me copy this and paste it here. We have to specify our input file location, which is /input, then the output location, and action on failure should be terminate cluster. So once this is done, we add it, click on next. I'm not changing the default settings for the creating the cluster. Here I will name my cluster CS441 homework 2, and now I will create a cluster. So now the cluster is starting and we have different tabs here. So if we go to steps, we can see that we have submitted our clusters. So the status for creating for running the jar file as well as for setting up the Hadoop debugging, it is right now pending. So we can refresh the logs. So nothing has been generated as of now because it is still starting the cluster. So this step will take around 10 minutes. So I will pause the video and will resume once it is done. So now we see that the cluster has terminated and both the status is completed. So if we see the logs, we see that like it started job 1, it ran job 1, it ran job 2, it ran job 3, and as well as it ran job 4. And we can see that in this it has created uh, the 3 reducers. Okay. So in our output file also we will contain 3 files. Now if we go to our S3 bucket and if we refresh this, we see that we have output folder. So this is job 1. Let me download all these files. So we can see that we have generated 3 files and it contains the count for the particular 10-minute of time interval. So we have debug and its count, info, warn, as well as error. Now I will change that. I will go to the settings and I will uh, change the format of these files to CSV. For that, the command is mv, the file name, and the file name we want to convert it to. So once these 3 files have been created, these 3 files, 3 CSV files have been generated. Now I will concatenate these 3 files into one file. So for that the command is cat.csv into uh, uh, this job1 underscore output dot csv. If we see, it has created one output file called csv. So we can see that it has created this log file. Since we had 3 reducers, so the output is not in sorted order. But if we create, so let me show you on the on the local HDFS, after the local HDFS run that I had. So here I am in my local, I am using one mapper and one reducer. So this is the input file, which looks like this. And it has generated similar outputs. So like seeing the output of first job, we see that it has created one file. As we can see, only one file got generated and the results are in sorted order. Similarly, for job 2, we can see only one file got generated and the counts are in sorted order, in descending sorted. Take the output of job 3, we can see that it contains all the count for entire time duration of the log file. This is the output of job 3. Now the output of job 4 is that we are fetching the maximum number of the maximum length of debug and of all the message types. Now going back to the job 2 intermediate result, this is the output of mapper job 2 and reducer job 2, where we see that the time, since time is the key, it is getting sorted in ascending order but not the values. But the main objective of this job is to get the values sorted in descending order. So that is why we use the concept of chaining, and we got the result in this step. So these are the 4 outputs, the 4 actual outputs of the task mentioned for this project, and I guess this is it. Thank you.